All right, folks, hopefully you enjoyed the music. That is from Disney's The Descendants. My daughter obviously picked that music for tonight. And I don't believe that any of you are rotten to the core, and I'm not rotten to the core. Hopefully you don't think that about me. But today for our 5.1 notes, we're going to talk about slope and rate of change, because you can change from what your parents are. According to the movie The Descendants, you don't have to be rotten if their parents are rotten. Not that any of your parents are rotten, but here we go. Rate of change and slope, the relationship between two changing quantities. Or slope, I like to think about slope as m. So m is equal to all of this stuff, and it's equal to the vertical change over the horizontal change, or the rise over the run, or y2 minus y1 over x2 minus x1, which is your formula. Or we can say that it's the change in y over the change in x. All right, there we go. Let's move on. All right, so our instructions for number 1 are to find the slope, and for number 1 through 3, find the slope of each of these lines. And so the big idea here is that we count the change in y, which in this case we're going up 1 spot and up 2 spots to get to there. And I'm actually going to erase that and draw a nice triangle. All right, and this is a rise of 2, or a change in y of positive 2. And then I'm going to put that over our change in x, which is 1. So I'm going to make a fraction of 2 over 1. And in algebra, we don't really write that fraction of 2 over 1. We simply just say 2, don't we? All right. So I think that you guys are probably going to get really used to this as we go through here. But this line here is in standard form. And I know that because we have an x-intercept right here and a y-intercept right there. And I can draw a nice pretty triangle where I've got a change in y right there of -4. Okay? And I've got a change in x right here of +4. And so I'm going to make a fraction of -4 over +4, which, if I plug that into my calculator, if I plug 4 divided by 4 into my calculator, I'm going to get a 1. And I've got a negative divided by a positive, which is going to be negative. So my slope is -1. All right. And then let's take a look at number 3. So I've got a change in y. All right. I'm not going to make my triangle on that side. I'm going to make my triangle on this side over here. I've got a change in y from this x-intercept to this point right up here of a +3. So it's going up 3. And my change in x, if I switch colors here, my change in x is going to be 2. So I've got +3 over 2. I'm going to make a fraction like that. Can't really reduce that or simplify that any further, and so I'll simply use that fraction as my slope. And something that I'd like to point out about the slope of all 3 of these lines is you're going to get pretty used to just simply looking at a line and quickly being able to tell whether or not it is going to have a positive slope or a negative slope. And if you're looking at this kind of like you would read a book going from left to right, all right, as we are looking at this line, it's going uphill as we go from left to right in this first line. So we have a positive slope. Notice that that's a +2 there. And in number 2, as we go left to right, it's like we're going downhill. If this ball was rolling down a hill, it would be kind of like bounce, bounce, bounce down the hill. And so subsequently, we have a minus sign or a negative slope in that particular case. All right, and then in this one, we have to go uphill, so we have a positive slope. So you guys should quickly be able to look at a graph and tell whether or not it's a negative or a positive slope just by simply looking at it and not knowing any other information. All right, so in number 4, we have a horizontal line, and in number 5 we have a vertical line. And this is an acronym that you can use to remember what the slope of a horizontal line would be, or what the slope of a vertical line would be, and it is HOIVUX. Yes, you do have to be careful of the way that you pronounce HOIVUX. But here we go. I think of a horizontal line, and when I think of horizontal, I think of the horizon. And so I think that that line is going to be just like that. And here we go. So we've got a line that is just like that. I'm going to use my laser pointer again. Got a line, just a horizon, sitting right there at y equals 3. So the equation of this line would be y is equal to 3. But don't confuse that with what our slope is going to be in this case, because our slope for a horizontal line is actually 0. And that's because we don't really have any rise and we don't really have any run happening in that particular case. So we would simply say 0 for our slope on number 4. And then on number 5, we've got the VUX part of of our acronym, and that is a vertical line. So let's switch back to our laser pointer again. I've got a vertical line happening here in number 5, and the equation of that line would be, oops, I started writing a y. It's not going to be a y. The equation of that line is going to be x is equal to whatever that spot on the x-axis is, which is 2. All right, so we've got x is equal to 2. We do not have a slope. It is actually undefined. All right, so I would write undefined for my slope in number 5. Little acronym. Hopefully that helps you. Okay, for number 6, the instructions are to find the slope of the line that passes through each pair of points. And guys, if you think about slope as rate of change, and you think about the formula, it'll start to make sense as we do these here, because we'll have the change in y over the change in x. That's what those little triangles mean. All right, change in x, and the formula for that is y2 minus y1 over x2 minus x1. All right. So if I know 2 points, and I know any 2 points, I can figure out what the slope of that line will be, and I can also figure out a whole lot more information than that, but today we're focusing on the slopes. If I know any 2 points, I can figure out what the slope of that line is, or what the m is going to be equal to. And so here's how we use that formula. I've got y2, which I'm going to use as 0. All right, that point right there. And then I've got minus y1, which I'm going to use this point here, over x2, which I'm going to use this point here, it's 0, minus x1, which is this point here, so minus 2. So in this case, I've got a negative 1 over a negative 2. And anytime I have a negative divided by a negative, well, that's a positive. So I've got a slope of a positive 1/2. All right, number 7. Number 7. We've got y2 minus y1. And so that is m is equal to y2, which is 5, minus y1, which is a negative 3. All right, inside of parentheses, over x2, which is 6, minus x1, which is negative 2. All right, so this is really 5 plus 3 over 6 plus 2, which is 8 over 8. And folks, if you plug that into your calculator, you will get a 1. All right. Speaking of 8 over 8, let's do number 8. So we've got m is equal to y2, which is 2, minus y1, which is 0, over x2, which is 4, minus x1, which is 1. We're going to end up with a 2 over a negative 5, which that's equal to a negative 2 over 5. I really can't reduce that any further, so there we have it. Okay, so our instructions for number 9 are each pair of points lies on a line with the given slope. Find x or y. I can tell you right now that I know that several of you are looking at this right now and freaking out. I promise you can do it. Okay? So, we've got our equation to figure out what slope is. It's m is equal to y2 minus y1 over x2 minus x1. Okay? So in this case, we're going to set that up as y minus 4, okay, y2 minus y1, over x2, which is 3, minus 7, okay? And that is going to be equal to 1/4, okay? Now all we have to do is algebraically manipulate this so we know what we have. So we've got, I'm going to rewrite this right over here. I've got y minus 4. And in my denominator, I've got 3 minus 7, which is a negative 4. And that is equal to 1/4. Okay? So what I'm going to do in my next step is I'm going to multiply both sides of this equation by a negative 4, because remember, when I'm solving for a variable, I want to get it all by itself. So I'm going to multiply both sides of my equation by a negative 4, and that's going to cause something interesting to happen. Okay? My negative 4 in the denominator right here and my negative 4 here are going to cancel out and go away. So I'll just be left with the left-hand side of being y minus 4, and that will be equal to something that's going to happen that's interesting here is this negative 4 and this 4 are going to cancel out, but that negative is still going to be sitting there. So my y minus 4 is going to be equal to a negative 1. All right? So the next step, I think most of you can figure out how to solve this from here, is I'm going to add 4 to both sides. And then I'm going to be left with y is equal to 3. All right? And if you wanted to, you could plug that back in to our point there for y, and make sure that your slope would actually equal 1/4, and you'd find out that it indeed does. Alright folks, number 10 is a very similar problem. I'm going to go ahead and start off by saying that I'm going to do y2, which is 6, minus y1, which is 5, over x2, which is negative 3, minus x1, which is x, over, and that is equal to negative 1. Alright, so I've got 6 minus 5 over negative 3 minus x. Well, 6 minus 5, well, that's 1. Okay, and I can simplify that. I've still got negative 3 minus x in the denominator, and that is equal to negative 1. And folks, what I'm going to do is get rid of that denominator with the x in the denominator. So I'm going to multiply both sides by negative 3 minus x. Alright, negative 3 minus x on both sides of my equality. That's going to cause on the left-hand side for those to cancel out, and I've got 1 is equal to negative 1 times negative 3 minus x, and I can distribute that negative 1 in there, so I'll have 3 plus x. Alright, and my next step would be to subtract 3 from both sides, and you would find that you have x is equal to 1 minus 3, which is a negative 2. Alright, and if you plug that back into your point for your x value, and recalculate your slope, you'd figure out that your slope is indeed negative 1. And folks, that is your notes for 5.1. I don't believe that any of you are actually rotten to the core, but enjoy the music video. Actually, just the music part of it.